Okay, in this video I'm going to show you how to slice the files from the Brancopan and turn them into G-code that your printer can interpret to make a physical object. Slicing is the process by which you take the shape file, which is an STL, and turn it into specific instructions for your particular printer. So the first thing you want to do is get Repetier host. You can download this for free. This has a couple of tabs. You've got an object placement tab where you can place objects on the print bed. You've got a slicer tab where we can calibrate the settings that we're going to use to turn those STLs into G-code. We've got a G-code viewer and a print panel. We're not going to look at the print panel. This is for controlling your printer directly through Repetier host. We're not going to do that. We'll use an SD card. So the first thing you want to do is go into printer settings in Repetier host. You don't really have to worry about connection, again, because we're not going to connect to the printer directly through Repetier. Behavior, similar. The thing you want to make sure that you have set is the dimensions of your print bed. You can set the minimum and maximum travel of your X and Y axes on your printer and the print area width and height. If you're using an Ender 3, you're looking at 220 by 220. These offsets might be 0 in one direction and something in another, or 0 in both. Check your printer and make sure that you've set this guy based upon your actual printer. Okay, the next thing that we want to do is go into Slicer and click Configure. This will pull up SLIC3R, which is a program that I like to call Slicer. Some people call it Slic3R. Programs that turn STL or object files into G-code are generically called Slicer, but if I say a slicer, I'm referring to a generic slicer. If I say slicer, then I'm referring to SLIC3R, which is the actual slicing software that's a plugin automatically associated with Repetier host. It'll come in the download. So if you haven't downloaded Slicer, go do that now and come back. So the two settings that we're going to set is filament settings and print settings. The filament comes first. We can go into the configure icon over here and look at the filament settings. Again, this will depend upon what filament you're using and your printer. I would recommend, if you are first starting out, that you print the CAMERADACTYL Brancopan in PLA. It's the easiest to work in. You could also print it in ABS if you don't mind the horrible, horrible smell that's probably killing you. Or a really good option is PETG. Each of these will come with a recommended temperature that you print it at. We're going to go over my base settings for PLA. Every different roll of PLA will have a recommended temperature range, and you should start with that. But here's kind of my base settings for most of the PLAs that I use, and probably should get you through most of the Brancopan prints. You might have to tinker with this a little bit depending upon your printer and your set of filament, but this is a good start if you haven't done it before. So the first thing we're going to look up here is the filament tab. We want to set the temperature for the first layer and all other layers. I like to print a little bit hot and print even hotter on the first layer for both the extruder and the bed. That will make sure that the filament sticks to the bed really nicely. So I printed 225C in the extruder and 60 on the bed in the first layer. And then for all other layers, I printed 220 for the extruder and 55 for the bed. You can add this optional information which will help you calculate the actual print cost of your G-code, but we don't really need that. Make sure your diameter is set to 1.75 millimeters. You could also get printers that print in 3 millimeter filament or 2.94 millimeter filament. Those are not really standard these days. Chances are you have 1.75 millimeter filament. Then we're going to look at cooling. We can set all of these settings manually to turn the fan on between certain values of speed based upon how long the layer takes to print. Each layer takes to print, but I think for pretty much all of these prints that we do today, enable auto cooling should take care of everything. We're not going to worry about custom G-code notes or override, just filament and cooling for the filament settings. We can go over here and save this profile for the filament settings. You might have a couple different filament settings, like this is my PLA standard setting, this is my PLA hot setting, this is the PETG setting, whatever. I have used this name, Brancopan Filament Profile, which is very similar to my standard PLA profile. Okay, so we can get out of there. Now we can make sure that we have the Brancopan Filament Profile, or whatever you've named your profiles, in the options. Now we're going to talk about print settings. Print settings are a little bit more involved. You can click the icon over here and open up the Print Settings tab. These are the rules by which the slicer will turn your object files into G-code for the printer. And there's a whole lot of rules. You might think, if you're new to 3D printing, that you would want to print everything with 100% infill and just fill the thing up. But that leads to its own problems, because the filament expands and contracts as it's being heated and cooled. If you print everything at 100% infill, you'll have some dimensional accuracy problems and curling. And there's also smarter ways that you can create a super strong part by just putting the filament in the right place. So I'm going to look first at what all of these tabs control in our print settings, and then we're going to create a couple different profiles for the different parts groups that we're going to print with different types of settings. So for each print settings, we have the layer height and first layer height. For all of the things we're going to do today, I'm going to leave these at 0.3 and 0.35. This is based on using a 0.4 millimeter nozzle to print 1.75 millimeter filament. You might print finer or thicker layer lines with different nozzles, but I would strongly recommend, if you're just starting out, using a 0.4 millimeter nozzle and using these layer heights, particularly on an Ender 3. The perimeters are the number of solid layers that are going to be printed on the sides of your objects, and then the solid layers are the number of solid plastic that they're going to print on the top and bottom of the object. These are some quality settings. We can set a seam position for if you're printing multiple objects on a bed, when the nozzle leaves one part to go print another part, you can have it leave the first object or enter the second object all at an aligned seam or at random points. I generally use aligned seams because they're easier to trim off, and I'm going to be doing a lot of trimming anyway. Then you have the infill tab. This will tell you how much of the inner part of the plastic inside of the shells is actually plastic versus air, and you can set this as a percentage. You can set a pattern that's going to be printed on the infill inside of the solid shell and top and bottom layers. Most of the things we're going to print today are rectilinear, but we can print all of these different patterns, and they have different strengths and weaknesses. I'm not going to go into that in this video, but you could go down a wormhole learning about these things. Anyway, rectilinear is perfectly fine for everything we're going to print. Then we get to external infill pattern. You can print concentric, which basically makes a spiral on the face that you've selected. So the top face on the print bed will be printed in a spiral. The bottom print face printed against the bed will be printed in a spiral. We can pick other surface finishes, Hilbert curves, Archimedean chords, or octagram spirals. I like octagram spirals as well, but this is really more of an aesthetic choice and doesn't have much to do with the strength of your final part. You're welcome to use any of these for any of the prints, but if you're starting out, I would highly recommend just starting with concentric and have your prints match mine. Let's see what else is important. You can set the fill angle, so the angle of the infill can be rotated with respect to your part. I like to print a 45-degree print angle on the infill. I feel like it's generally the most isotropic or the strongest in the maximum number of dimensions. Then you have these two options, which is only retract when crossing perimeters, which I usually leave on. You may or may not have thinner or thicker filament that will ooze or not ooze, and you might get stringing, and this could prevent that inside or outside the part. And then infill before perimeters, depending upon what you are printing, you may have reason, generally because of thermal warping, to print the infill first or the perimeters first. I generally leave this off. I print the perimeters first and then infill. The next tab is skirt and brim. The skirt is basically just a line that it'll print around your area of all of the pieces you're printing on the print bed, and that's basically to prime the nozzle and clean it before it starts printing the actual part. Pretty much on everything that I'm printing, I use one loop at 6 millimeters away from the part, and I only print one layer high, and that's generally good enough to prime the nozzle, wipe any gunk off of it before I start printing, and just make sure that the print bed is level before I let the print go. The brim is much like the skirt, except it's attached to the object. This will create something that looks kind of like flashing in an injection mold. It's basically a lip that's 1 or 2 layers high around the base of the object as it's printed to the print bed to prevent it from curling. None of the Brancopan pieces need this per se, but you might find if you have a particularly obstinate part that's curling on you, first I would say try and level your print bed, but if that doesn't work, you may need to add a brim and just trim that off later. Now let's go to the support material tab. That is really important. You can make no support by not checking this generate support material. If you do generate support material, you can choose the angle or percentage overhang threshold at which it starts to print support under your piece. Because the filament comes out of the nozzle as almost a liquid, if you print an overhang, it's going to droop down. And so it's really important to print some support material that it can sit on top of and you can trim off later. We will need to print some objects with support and some without support, and we're going to create many profiles to do that. I never use a raft. I hate them. I don't think they're really useful these days in modern printers. I'm not going to talk about that here. You can go way into that. You can also set a support pattern. We will use some supports that are pillars and some supports that are honeycomb, and the pattern spacing and angle of those supports. You can also set the interface layers, which is the number of layers at the top of the support before it starts printing the bottom of your actual part. And then we have the speed tab. The speed tab determines how fast your print head can move during different types of operations while drawing your part on the print bed. These are my standard print speeds that I use for all of these operations, and I'm going to use these across all of the different profiles that we make today. These are really calibrated towards my printers. Works pretty good on the Ender 3. You may or may not tweak these. Basically what you're going to try and do is print as fast as you can before the printer prints so fast that you start having errors, poor finishes on certain parts. I would say that this is just about optimized for the Ender to get as fast as you can go without any deleterious effects on the print quality. These tabs down here, we're not going to worry about multiple extruders. We don't need one to print the Brancopan. Forget about these for now. To print all of the pieces for the Brancopan, you're going to need 5 different print settings profiles. I've named them NB, NG, that stands for no support body, no support gears, and then S1, S2, and S3. Those are supported 1, supported 2, and supported 3. S1 is for supported body pieces, S2 is for supported gears, and S3 is for supported plate or body pieces, and we'll see which ones wind up using which profiles in a bit. So let's just go through some of the settings of each one of these, and I'll put the list of settings so you can just read them, but you should go through this video and see. So first one is NB, that's not supported body pieces, and we've been looking at that as an example. So I'm going to print, again, 0.3 millimeter layer height, and the first layer a little thicker. I'm going to print 4 perimeters and then 4 solid layers on the top and bottom. I'm going to turn all of these quality settings on. I'm going to leave the seam position aligned. And then if I go into the infill tab, I'm going to print 30% infill in a rectilinear pattern with concentric top and bottom. Again, you can change these for aesthetic reasons on just about any of the prints. I'm going to combine infill every 1 layer. Solid infill every 0 layers. We don't need any solid layers going through the middle of the pieces. That's unnecessary. Fill angle of 45%. Yeah, these are these settings. Then we're going to go to skirt and brim. I use these skirt and brim settings for everything. I'm not going to go over them for all of the other settings. I'm just making one loop 6 millimeters away from all of the pieces, and I'm making a 1 layer height skirt. I'm not going to use a brim on any of these, but again, if you have trouble printing some of them, you might want to create an additional print setting with a brim. This will help prevent curling on certain pieces if you have a printer that's either not as precise or not calibrated as well. So the support material, you don't have to worry about any of these settings because we're not generating support for the NB print setting. It's a not supported body piece. So then when you're done, set these speeds to start with. You might have to tweak them if you find that your printer is getting some errors here and there because it's moving too fast, or you might want to try increasing some of these speeds to try and get a faster print. I would increase them little by little until your printer fails if you're really trying to optimize your print speed, and then once it fails, then dial it back. That could take you months to figure out perfectly, but start with these if you don't already have a profile for your printer and see what you need to do. Okay, so once you're done with that, hit save, and then I highly recommend that you save this profile as NB. It'll match up to the file name suffixes that I have added to all of the files, indicating which profile I would start printing them with. So we're going to save that. Okay, I'm going to click cancel because I've already saved it. The next one is NG. These are non-supported gears, and we're going to print the gears a little bit differently. Mostly they're going to have much more infill, so they can be small and strong pieces. Again, same layer heights. I'm going to print 6 perimeters, 6 layers top and bottom this time. For the quality settings, I have all of these turned on except avoid crossing perimeters. The seam is again aligned. The infill this time, I'm printing at 90%. Again, the fill pattern and external infill pattern, which is the pattern on the top and bottom, are all the same, rectilinear, concentric, and concentric, and all of these settings are the same from the last. Then we've got skirt and brim, again the same, and then support material, again, is turned off because these are non-supported gears. Speeds, all the same. So go ahead and save this as NG. I'm going to cancel. Now let's go to S1. I've got V2.3. You don't need to name it V2.3. I've done some tweaks to this, but this you can call S1. Again, same layer heights. I have used adaptive slicing on this. That'll speed some things up for this type of print. I set adaptive quality to 75%. My vertical shell perimeter count is 5. The top and bottom layers, solid layers, are 6 each. And this is actually really important. We're going to do some trimming, particularly on the bottom layers of the body, which we're going to print with the S1 profile. And you really need at least 6 layers, just, at least 5, but print 6, just so that when we do some trimming, we're not going to cut into the infill and open up the body. In the quality, I have all of these checked on except avoid crossing perimeters. The seam is aligned. Let's go to the infill. We're printing, again, 30% infill. That's perfectly fine for the body. You could probably get away with less, but this is a really strong piece of plastic. The fill pattern, again, is rectilinear, concentric on top and bottom, combining infill every layer. Then skirt and brim is the same. The support material is where this starts to get interesting. So this is the supported body pieces. We're going to generate support material. The overhang threshold is 15 degrees where it starts printing. Anything less than that will not print support underneath. So you can print some angle of overhang before things start to droop, because if half of a line is printed on top of another line and the other half is overhanging, it won't droop entirely, and you can get away with some angled overhang. You can't get away with a big piece sticking out horizontally, cantilevered like Falling Waters, that Frank Lloyd Wright house in Pittsburgh, but you can get away with kind of like an upside down pyramid up to a certain angle. Anyway, for S1, I have found 15 degree overhang threshold is great. These settings are 0. The contact Z distance is 0.2, which is detachable. That's pretty standard. The pattern is honeycomb. Pattern spacing is 5 millimeters. Interface layers are always 3 when I'm using supports. I don't support on build plate only because I want this to also support things that are, overhanging, but overhanging above another piece of the body. This is really important that you don't have this checked on, and don't support bridges I have on. Bridges are sort of a overhang that spans between two pillars or two sides of something. Generally, for the Brancopan body, none of the bridges are so large that things will droop, and you can get away with a lot less support in here. The speeds are the same. Again, we're going to ignore these, so when you save this as S1, I have V2.3 because I've been fiddling around with some things on my computer to optimize this for you, but you can just call it S1. That is the suffix indicated on some body pieces that need to be printed with S1. Okay, I'm going to click cancel. Now let's look at S2, and we're almost there. S2, again, same layer heights, 6 perimeters, 6 top and bottom shell, or 6 top and bottom solid layers. All of these are checked on except avoid crossing perimeters. The seam position is aligned. For infill, we are going to print 90% infill. Again, this is for gears, so they're nice and dense and strong teeth. Rectilinear infill pattern, concentric top and bottom. Again, these are cosmetic, so you can change them around, but it won't make much of a difference. All of these pieces pretty much are internal. These are the settings down here. I'll again put them in a list. Skirt and brim is the same. Support material is important that you pay attention to this one on S2. Again, we're going to generate support material. The overhang threshold is 10% this time. We're going to use a honeycomb grid, this time at 4 millimeter pattern spacing. Again, 3 interface layers. We are going to support on build plate only for S2, and we are going to support bridges. So these are checked oppositely from the last time. Speeds are the same. Go up here, save this as S2. That'll correspond to the suffix of all of the parts that need to be printed with the S2 profile. You click OK, I click cancel because I've already saved it. And then we can go to S3. This corresponds to supported body plates for the most part. We've got the same layer heights as everything else. We're printing 4 perimeters and 4 top and bottom layers. These are the quality settings. The seam is aligned again. Infill is 30% on these guys. These are generally plates that don't have like moving teeth or anything and don't need to be incredibly strong. 30% is plenty strong for the pieces that they are. These are the settings that I have used here. Then the skirt and brim is the same. The support material, we're going to generate support material. We're going to use an overhang threshold of 1%. Keep in mind, sometimes I specify in percent and sometimes I don't use a percent. If you don't use a percent, it's degrees. Percent is like a road grade. Make sure that if I use percent, you use percent, and if I don't use percent, you don't use percent, at least if you're trying to match me for now. You might fiddle around with these to match your printer if you have some errors, but let's start out everybody printing like me. Okay, so again, no raft. We have honeycomb pattern at 4 millimeter pattern spacing. The speeds are all the same, and so you can go ahead and save this guy as S3. Okay, now that we've made our 5 profiles, which is S3, S2, S1, NG, and NB, we can go ahead and close the slicer, and you should be able to see over here in the print settings that I have all of those options to slice things with. The next thing we're going to do is put some things on the print bed and slice them. Okay, so we go into the Object Placement tab over here. We click Add STL. Then we can go into the Brancopan Kickstarter files, and you'll have this set of STL files. So the first thing you might want to slice, and we'll do these to test, is some of the calibration files that I've made for you to check the dimensional accuracy, the bed leveling, and the perpendicularity of your rails. Let's slice this guy first. Click Open. I've taken the liberty of orienting every STL file as they should be oriented on the bed, so you shouldn't have to rotate these, but you could rotate them around if you wanted to print them in a different angle for some reason, but they all should be oriented correctly and dropped onto the bed, centered when you open the file. Then I can go in here and say, let's say I want to slice it. I actually want to slice it with the NB profile. That's low infill with no support. And you could just use this pattern or the beginning of this pattern to level your print bed and check that everything is perpendicular. So I'm going to go ahead and click Slice with Slicer, and then pretty quickly it shows me the G code, which I can look at all of the code in the instructions to the printer over here. I can also look at the entirety of the G code. I can zoom in or shift around, and if we shift around here, we can see actually a lot of little lines, and these are all of the, in dark blue, all of the lines, filament that the printer is going to lay down, and in light blue over here, these are moves of the nozzle where it's not extruding. We can click down here where it says Show Single Layer, and we can look at individual layers on the print, and so it's kind of like a CAT scan. You're looking at slices of the object, right? First, the slicer will take your object and turn it into a bunch of horizontal slices, and then it'll turn each one of those slices into a contiguous tool path where it's going to extrude material into the shape of your object. Anyway, if we look at this from the side and I go up layers, we should be able to see this guy moving up. Right? We can zoom in here a little bit, shift up, going down. Okay, and then we can show the complete G code and move around. Anyway, once you're done with that, we can save this. I'm going to go back to here. I'm going to create a new folder, and I'm going to call it Brancopan G code. Create that folder. I'm going to call this Calibration Test Bed Leveling and Perpendicularity. Okay, save that. Now I'm going to go back to the Object Placement tab, remove this. I'm going to add a new one and quickly slice the other dimensional accuracy test that I've made. This is just a 20 millimeter cube. It'll tell you if you use a dial calipers or something like that to see if any of your axis belts are stretched or if you're printing within tolerance in the X, Y, and Z dimensions. There are also, I should mention, really great test pieces. The Benchy comes to mind, which is a more complicated item that you can slice to test different parameters and different abilities of your printer, troubleshoot it a little bit. I'm not going to get into that here, but look up the Benchy and printer tests and calibration if you're having any issues calibrating your Ender or whatever other printer you've got. Okay, so I'm going to go into Slicer. Again, I'm going to slice this with NB. I'm going to click Slice with Slicer, and there's my G code. Once again, we can look at the single layer at a time. We can see that 30% infill pattern alternating left and right, or at 45-degree angles to the part. We can look at the whole G code, and then we can save this G code. Again, I'm going to put it in the Brancopan G code folder that I just created, and I'm going to call this Calibration 2 Dimensional Accuracy. Okay. My spelling is terrible. Okay, so now you should have, printed these two things out at least on your printer. You can skip this step if you already have a perfectly working printer and you've been printing things for years, obviously. But at this point, I would go and try and print those two objects before we go further, see if you need any tweaking of your printer settings or filament settings before you go slicing everything else. But now that we're ready, we can remove this STL file and start adding pieces that we're actually going to use in the camera. So note that every file, right, and I've grouped these into the body files, the counter mechanism, the door mechanism, all of the finders for all of the lenses that Mamiya Press released. I've got mount files. We've got README that has no files. You need to print the rewind knob and the wind mechanism. Anyway, what I'm getting at is every file is labeled with a prefix and a suffix. The first part of the file name, W, is the designation for the wind mechanism. 4 means it's the fourth piece. And then it has a suffix, which is S2 or NG, NB, S1, or S3. And all of those will tell you which printer profile I want you to slice each piece to be printed at. I also have added a secondary suffix called color for those pieces that don't necessarily need to be black. You could tinker around with printing all sorts of wild colors, but you're going to have to be conscious that they don't leak light. You can't print the back door in a clear color without painting it, otherwise you'll fog your film. But these ones are the ones that are obvious to me that you can print in any color and it doesn't matter. They don't affect any of the light sealing in the body. Okay, so the first thing, let's print all of the NB pieces. So I'm going to go first to the body and select all of these guys that are NB. Oops. Control, not Shift. Add these to the print bed. I'm going to click auto position and it'll lay them out. I'm going to look at this from the top. Looks like we have some more space on the print bed that we could print some things. Again, I'm going to print everything as if I was printing things black. This grip can be printed in color. I need to add the color suffix to the file. You can then print it in another color if you wanted to print it in, say, hot pink, but print these in black. Go ahead, separate it out from the body. But I'm, for the purposes of this video, going to assume that we're printing everything in black, and we're going to throw everything that can go on the same print bed on the same print bed. Okay, so I'm going to add another STL file. I'm going to go down to the counter mechanism and see if there's any files with the suffix NB. There are not. Let's try the door mechanism. Yep, I've got this one and I've got this one. So let's throw those on the print bed, hit auto position. Okay, looks like I still have a little bit of room. And you don't need to put everything on the same print. I'm just doing it for speed and production. You can print things one at a time if you want. It's really up to you. We're not going to worry about printing the finders. Let's look at the mount. These are both NB, but I know that these are too big to fit on the print bed, so we'll get back to those. The rewind knob has no NB, and the wind mechanism has no NB. Okay, so cancel. Now, I've got everything laid out on the print bed, and you can tweak these by moving, one piece around. If you move pieces around, I like to, at the end, select everything, and then click Drop Object to make sure that everything is dropped to be flat against the print bed. And again, they're oriented naturally in the way that I think they should be printed in the print bed. Then you're going to go over here to Slicer. You're going to select the NB profile and make sure your extruder settings are that filament setting we set in the very first step, and click Slice with Slicer. This might take a while now that you have a complicated file. Just give it a minute, go away, have a cup of coffee, come back depending upon how fast or slow your computer is, and we're going to generate a set of G-code for printing all of these pieces on one print bed. Took a little bit of time, but now we have a full G-code slice of this first group that we made. You can see all of the extrusions in dark blue and all of the moves where the print head is not extruding in light blue. We can again look at single layers and toggle up and down to see everything being printed. So let's go to the first layer here. We can see everything coming up as we look through the layers. Okay, so now I want to save this. Again, I'm going to go into the Brancopan G-code file we created earlier, and I suggest that you name these by group numbers. So I'm going to name this group 1. I'm going to also say NB so that I know I've sliced this with NB. You can add any other designations, describe what's in there, whatnot, but this should be fun. Okay, so we're going to save that, and later we'll be able to put that on an SD card, throw it in the printer, and print it. Save. Okay, so I'm going to go back to object placement. I'm going to select everything. I'm going to remove the STL files. And now I know that the only other NB suffix files that were there were in the mount. You might want to print these in 2 different pieces or 2 different prints in 2 different colors. I kind of like how that looks, but for sake of simplicity, I'm going to slice them in one print. So I'm going to click auto position. This says printer bed full, that it doesn't have enough room to auto layout these guys, but I know that they'll both fit if I have them a little closer than the rules for auto layout will allow. So I can just move these like this. Again, I'm going to go into the slicer, same settings as before, hit slice with slicer, and it will turn it into G-code. Okay, so now that the slicer is done slicing these guys, we can look at the full G-code or single layers. Any single layer on the slider bar should give us those layers. Anyway, we can save this now. I'm going to save it again in the G-code folder that I'm going to put on my SD card. I'm going to call this group 2 NB, and I'll say mount rings. Okay, save that. Now back to the object placement, select everything, remove it. Now let's go to all of the NG pieces. So let's see, are there any NGs in here? None. Okay, let's try the counter mechanism. Oh, all of these are NGs. This is an NG. Again, it could be printed in color, but I'm just going to print it in black, and this is an NG. I'm going to open these. They should all be oriented to the print bed correctly. I'm going to hit auto position. I have plenty of extra space, so let's add some more STL files. Let's see if there's any NGs in the door mechanism. There's one. Let's put that out. Again, hit auto position. Let's see, we've got more space. I'm going to skip the finders again. Let's look at the mount. Nope. The rewind knob. Nope. And the wind mechanism. The wind mechanism has plenty of NGs, so I'm going to select all of them, even the color ones, as if we're printing everything in black. And those are all of the NG pieces. And these are non-supported gears. I'm going to hit auto position again. It lays everything out. I'm going to go into Slicer. I'm going to make sure that I hit the NG profile for the print settings, and I'm going to hit Slice with Slicer. This might take a minute again because there's some complicated geometries in here. And let's just hang out and see what it does. Okay, the slicer's done slicing, and I can see the complete G-code of this print, and I can also look at every single layer just as usual. Now the next thing I'm going to do is save this G-code. I'm going to put it again in the G-code folder that I'm going to put on the SD card. I'm going to name it G group 3 NG. And that's good enough. Save it. Okay, back to the object placement. Remove all these STLs, add the STLs. Now let's go for all of the S1 pieces. Let's see, open. The body should take up everything on the build plate. There, I think, is one more S1 supported body piece, but it won't fit on this print. So let's go to S1. You should have named it just S1. Mine is version 2.3 because I've tried this out a bunch. Click Slice with Slicer. This one's going to take a really long time to slice, so go have a beer and come on back unless you got a sweet computer. Okay, the slicer looks like it's done with this slice. It's good to note that we can take a look at the support material over here that it's generated to hold up this overhanging piece and some other support materials. And again, we can look at single layers and see how it's being printed. Okay, we're going to go save this, and I'm going to put it in the G-code folder. I'm going to call it group 4 S1 body. Okay. Again, back to the object placement tab, remove the STL, add an STL file. Let's see what else we've got that has S1 designation. None of these. None of these. This guy. And let me just check. I think there's nothing else that's S1 in here. I am correct. So it's just these two, the body and the door, that are S1. Again, I'm going to go into Slicer, make sure I have S1 selected, click with Slice with Slicer, and we're going to come on back when this is sliced. Okay, it looks like it's done slicing. You can see the entire object sliced, and we can see some support material under here, under the hooks, holding up the overhangs. So you could look at all of the layers if you want, but I'm just going to go ahead and save. I'm going to put it in the G-code folder. I'm going to call this group 5 and nope, S1 door. Okay, save that. I'm going to go back into the object tab, remove the STL file, add STL. Now we're going to go through and add all of the S2s. There are none in the body. There's one in the counter mechanism. There's one in the door mechanism. rewind knob has one S2. And the wind mechanism has a bunch of S2s. Open those up, auto position them, take a look at the top, make sure they're spaced, and they are. I'm going to go into the slicer, I'm going to select my S2 profile that we created earlier, and then I'm going to click Slice with Slicer. We'll come back in a few minutes when this is done slicing. Okay, and we're back. We've got all of these pieces sliced. I'm going to go ahead and just save it. Again, in the G-code folder, I'm going to call this Group 6, and this is S2. Okay, we'll save that. Back to the Object Placement tab, remove all the STLs, add the STLs, and then the last pieces we need to print are the S3 designations. So we've got these two in the body folder. Position them. Let's look at this from the top. Let's add an STL file. Counter mechanism. Does this have no S3s? Door mechanism. No S3s. Mount has no S3s. The rewind knob has one S3. Throw that on. Hit auto position. Still have space. Add file. Let's go to the wind mechanism. And there's no S3s in here either. Let me just double check. Got that one. Okay. So these are the only pieces that need to be printed with the S3 profile. I'm going to go back into Slicer. I'm going to check S3 as the print settings that we created earlier. I'm going to click Slice with Slicer, and we're going to come back in a minute when this is turned into G-code. Okay, and we're back, and we've got the G-code for this set of files. I'm going to save it. I'm going to put it in this folder for the G-code. Call it Group 7 S3. Okay, now you've sliced and saved all of the pieces. Again, if you were going to print some in color, you might want to split those off into separate groups for printing in red or blue or yellow or whatever color you want to print them in. Now you can take all of these files, throw them on an SD card, and pop them in your printer and print. I like to print this calibration test first before I do anything else. It allows me to print lines along all of the edges of my print bed and just make sure that the nozzle is an even height above the print bed and nice and level as it moves around. While it's printing this, I like to screw the adjustment screws on the bottom of the print bed at each of the four corners to make sure that it's printing a nice even line. I might restart the first layer a couple of times if it takes me longer than the first layer to get that dialed in. Usually it doesn't now, but the first time maybe I would have had to print it 3 or 4 times before I got everything perfect. There's certainly the piece of paper method, and you can watch a lot of YouTube videos on how to calibrate and level your print bed. But for me, this is the nicest file that I've used to do that while it's moving. Don't catch your fingers or your beard in any of the belts or pulleys or anything like that. I've pulled out a lot of beard hairs getting too close to my ender, but relatively safe and simple way to make sure that your print bed is leveled. So there's a lot of great videos out there on the internet about leveling and calibrating your printer and troubleshooting videos. I would highly recommend Thomas Santander and Joel the 3D Printing Nerd. I'll answer some questions if you guys have some specific ones and do a live stream just answering 3D printer questions. I'm not going to get into that in this video, but I just wanted to make a quick video on all of the print and slicer settings that I use to slice the parts for the Brancopan. You should be good to go and ready to print all your pieces. I'll see you in the next video where we assemble all those pieces into a camera. Thanks for watching.